Let's take a look at the questions on homework number 6. The first topic is checking to see whether a value makes an equation true. This is a guess and check question. Now we can certainly solve this using inverse operations, but we do want you to spend some time practicing checking whether a solution is true. Because for the next topics, when you have no choice for the answers and you're asked to solve the equation on your own, you'll need to use a check step like this. So the first thing you would do is choose one of these numbers, erase and replace the variable you're given, and then compute. 7 times 4 is 28. 28 minus 3 is not equal to 4. So 4 is not the correct value. Let's try number 1. 7 times 1 is 7. 7 minus 3 is 4. When the left side and the right side equal the same value, then you have found the solution. That is a check step. Another type of question you might see in this section is when you're given the value of x and you have to see which one of these equations it would be true for. You're going to use that same check step routine. You're going to erase and replace the value of the variable with the number you're given. So we're going to erase the x and replace it with a 3. And then we're going to check. You can pick up your calculator and type all of this at once, or you can compute it using mental math. 9 plus 8 is not 41. So this is not the correct solution. Again, with our next equation, we're going to erase and replace the variable x with a 3. And 27 plus 1 is not negative 28. And then we continue. Over here, we'll erase and replace the letter x with a 3, and 12 minus 2 is in fact 10. So we found our solution. The next topic is solving a 3-step linear equation. Here you have no multiple choice options, and you'll type your answer in this field. When you're solving a multi-step equation, remember that you can only combine like terms if they're on the same side. You'll notice that 6x and 8x are not on the same side of the equal sign. Therefore, they cannot be combined yet. What we want to do here is use an inverse operation to remove one of these variable terms from the left side and rewrite it so that we can combine them on the right side. Now we can focus on the constants. 4 and 8 are like terms, but they're not on the same side. So be careful here. You're going to want to subtract 8, not 4, because 4 is the only thing on the left side, so we don't want to make it a 0. Now we're going to rewrite and use our final inverse operation of dividing both sides by 2 to get our final value. Now, just like in your first activity of this homework, you're going to check this response by using it in your original equation. Our original equation was 6x plus 4 equals 8x plus 8. We're going to erase and replace all of the letter x's with parentheses first, and then our value of negative 2. We're going to want to check that the left side and the right side are equal to the same value. So 6 times negative 2 is negative 12, and negative 12 plus 4 is negative 8. On the right side, 8 times negative 2 is negative 16, and negative 16 plus 8 is also negative 8. This statement is true, so our answer is correct. We'll type that answer here using our keyboard, or we could use the keyboard from Delta Math. Let's take a look at the next section, fractional linear equations. In these examples, you'll have a fractional coefficient that needs to be distributed to every term inside the parentheses. So we're going to multiply 1/2 times x and 1/2 times 4, leaving the equal sign and the 10 where they are. Now on my right-hand side, I have two unlike terms. And on my left-hand side, I have a constant. So I want this positive 2 to subtract from both sides so that my constants can be combined. When you have a coefficient that's a fraction, we're not going to divide, because when you divide by a fraction, you really multiply by the reciprocal. So we're going to multiply both sides by the reciprocal of 2 over 1, which you could also write as just a 2. Don't forget to use your check step to see if you are correct. The next topic on the homework is solving linear equations with distribution. When you distribute, that is the act of removing these parentheses by multiplying everything inside the group by the coefficient outside. In this particular example, the coefficient here is a negative sign. And you can imagine that there's really a 1 in that position. So we're going to multiply -1 times each of these items inside the parentheses. -1 times -x is positive x, and -1 times subtraction 1 is the same as -1 times -1, which is a positive 1. On the right-hand side, this -x is not the distributing value. The distributing value is only the item that's touching the parentheses, and that's this positive 3. So we're going to rewrite this minus -x, right? This -x here, we're going to bring it down, and then we're going to distribute this positive 3 times each of the terms inside the group. So 3 times -x is -3x, and 3 times positive 7 is positive 21, and the plus 6 gets rewritten. On our right side, we have several terms that are alike. We have a -x and a subtraction 3x. And when we combine these two together, we get -4x. We also have a constant of positive 21 and positive 6. And when we combine those together, we get a positive 27. Now, I'm going to get my x terms on the same side by adding 4x on the right and on the left. In doing this, I get a positive 5x, bring down the plus 1, bring down the 27. Now I'm going to subtract 1 from both sides. This will give me 5x is equal to 26, and then divide both sides by 5, giving me an answer of x is equal to 5.2. Now you can use a check step to check your answer. As a reminder, when you're distributing, you're only allowed to distribute whatever directly touches the parentheses, not something that comes before that. So in this example, the 6x is not being distributed. This negative sign is being distributed, and you can imagine it as a -1. -1 times -3x is positive 3x. -1 times 3 is -3. Combine like terms on the left side by performing the operation that you see between them. So 6x plus 3x makes 9x. And now I need to move x's from one side to the other so that I can combine them. I'm going to use an inverse operation in order to do that, giving me 5x minus 3 equals -3. I'm going to add 3 to both sides, giving me 5x equals 0, and dividing both sides by 5. x is equal to 0, and yes, that is a possible solution. Let's take a look at these next few topics that involve equations that might have one solution, no solutions, or infinite solutions. So you might need a bit of a refresher. Take a look at these three equations. Before I've done any math, I already know that this equation has one and only one possible number that would work for the letter x. I know that this equation has no possible numbers that will work for the letter x, and I know that this equation has an infinite amount of numbers that would also work for x. And those are the only three outcomes possible when solving an equation. So maybe you're wondering, how did I know just by looking without solving them and isolating x? And there's one easy trick, and it's to look at your variable terms. These are the variable terms. And you'll notice, when my equation has one of these special solutions, that the variable terms on the left and the right are a perfect match. That has to happen in order to have one of these special solutions. If ever your variable terms on the left and the right are not a perfect match, then it definitely has a number as the solution, a single number only. So that's what you're looking for. You're looking for matching or same variable terms. And once you have that, one of these two things might occur. You might have no solutions, or you might have infinite solutions. So how do you know? You look at the constants. It always starts with a matching variable term. If the constants are different, then there's no possible solution. But if the constants are the same, then there are an infinite number of solutions. So let's try another real quick. We have matching variable terms. So now we look at our constants. If the constants are a perfect match, then that means we have infinite solutions. You see how the left and the right side are a perfect match? If I had x plus 4 equals x plus 8, we have the matching variable terms, so one of these is the option. But since our constants are different, then there is no solution. Let's take a look at this question here. When I distribute on the left, I get negative 2x minus 8. And when I distribute on the right, I get positive 3x minus 3. I can see already that I have different variable terms. So I know that this equation has an answer. X is equal to some number. I just don't know what it is yet. I can use my inverse operations to figure it out. So negative 5x minus 8 is equal to negative 3. Negative 5x is equal to 5. And if I divide both sides by negative 5, I get x is equal to negative 1. So now when I click on this drop-down menu, I would choose that it has one solution. And I know that because it had mismatching or different variable terms. And since I solved the math, I know that it has an answer of negative 1. Let's take a look at another problem. When I distribute on the left-hand side here, I get negative 15x and positive 21. And when I distribute on the right-hand side, over here, I get negative 15x and positive 20. So there it is. Matching variable terms. I now know these are my only answer options. The next thing I need to do is look at my constants. The constants are different. And if they're different, that means there is no possible solution. So this time, when I click on the drop-down menu, I'm going to say there are no solutions. Let's take a look at the last two topics. This one is really going to ask you to think about what you need to have in order to make one solution happen. So if I want this equation up here to have one solution, then I cannot have matching variable terms. So it will have one solution when h is equal to any number in the universe but 4. So I can put any number I want in this box, but I cannot put the number 4. I can put a 6, I can put a 12, I can put a negative 13, I can even put a negative 4, because the only thing h cannot be is positive 4, because you get one solution when you have a different number of x's on either side, and these constants here don't matter at all. As soon as you have different variable terms, it doesn't matter about the constants. They can match or they can be different. So the constants can be the same or different. It doesn't matter. The only thing that matters is that you have variable terms that do not match. So let's try another one. This equation will have infinitely many solutions when the variable terms match, check, and the constants match. So we need to make that check. So this letter h can only be the number 6. And we know that because we have the same number of x's on either side and we have the same constant value. In this question, they want to know how will you get no solutions, also known as 0 solutions. Again, that is a special answer, and it can only happen if your variable terms are a perfect match. So if I have a 3x on the left, I must have a 3x on the right. So h would need to be 3, because you get no solutions or 0 solutions when you have the same number of x's and you have different constants. The last topic is similar, but you have to do a little more thinking. We want this equation to have one solution, so I know that my x's have to be different. So if I were to distribute 12 on the left, I would get 12x. Now, on the right, I cannot get a 12x, because if I do, I will have a special solution, and I want one solution. So I need any number in the universe, but not a number that will make this 2 turn into a 12. So 2 multiplied by 6 would make 12. So I can put any number I want in this box, but I cannot put the number 6. So I'm going to put a 3 here, because I get one solution when I have different x's on either side and the constants never matter. One more time. I want there to be no solutions. In order for you to have no solutions, your x's have to match. So if the left side has negative 12x, the right side needs to have a negative 12x. And the only way for that to happen is the number in the h position would have to be a 6. Because I will have no solutions, 0 solutions, when my x's are the same and my constants are different. And that concludes homework number 6.